Security manager, in case of application program, by default there is no restriction placed by the security manager. If you want, you can specify whatever restriction you want to place for the application, like who can access a particular class, or what are the things that a particular class can do, or what resources can be accessed, all such things through a policy file. In case of an applet, security manager plays a very big role, because applets run on a client browser. Now when I run a program on a client browser, the client would not want some program, external program, to access his private data, his private drive or the private network drive. Okay, so applet security manager plays a role in this. The security manager for an applet says, the sandbox, it says an applet cannot access the local drive nor the local network drive. This is the restriction placed by the security manager for a JVM for an applet, in a JVM for an applet. For application, since it's a standalone program in your own machine, there is no restriction placed by the security manager. Then the execution engine. Execution engine is the one which is actually responsible for converting your byte code to the machine code. Now, execution engine started as an interpreter in 1.1 JDK and 1.0, where every line it interpreted to a machine code executed. This was very slow. At that point, Java was slower for about 10 to 13 times than C++. Then later in 1.2, the execution engine was modified to a JIT, just-in-time compilation. So what happened with the JIT is they provided with the cache memory. So whatever code that was compiled, it was interpreted, it was placed into the cache. Because remember, in the 1.1, it was just an interpreter. So if imagine I had a while loop for 100 times. The same set of instructions, 100 times I am interpreting and executing. Right? But with cache being made available in 1.2 JIT, once I interpret the code, I put it into a cache. So next time I need to execute the same code, okay, it just needs to take it from the cache and execute the code. I don't have to reinterpret it. Whereas in case of 1.3, the execution engine has been converted to a hotspot JVM. Again, why? Because our cache also is limited, right? So here with the hotspot JVM, using certain algorithm, it finds out what is the critical path in my code. Only such code would be compiled and placed into the cache. The rest of the code would be interpreted on its way of execution, and it executes the program. So this is how the execution engine has been enhanced to speed the Java execution, program execution. So as you can see, there is a lot of process involved in executing your Java program within the JVM itself, which is a cause for Java being slow, one of the reasons for it being slow. The JVM depends on your OS. So when you actually download a JDK kit, it will ask you for which OS you want to download the JDK for. So if your code has to be independent, there has to be some layer which is dependent on the OS, and that is the JVM. And these are the components of the JVM.